Hello everyone and welcome back. So in this video I wanted to show you a quick way to have a more pleasing result with the lot subdivision labs tool, because usually when we feed a flat plane to a lot subdivision we get this fixed theme, fixed edge due to the first iteration of the lot subdivision, as you can see. And one way we can randomize it is to introduce and avoid that theme is to introduce a cut, a random cut, and we get a more pleasing result. So let's have a look on how to achieve that with Vex. So let's drop a geocontainer and a grid. 10 by 10 will be fine. The idea is to introduce a random cut and have some procedural way to control it. So we're going to do a bit of a Vex exercise. I'm just going to drop these columns to 4 because I don't want too many divisions. And the first thing we're going to do is to create a column and a row attribute. So for that, I'm going to drop a wrangle. And we're going to reference the columns and rows from this grid geometry. So we can create an int called rows, and let's create a channel integer called rows, and we will copy this and do it for columns and call it calls. And let's create that and copy from here the rows. So rows, space relative reference, and columns, copy and paste. Now we will create the attribute, so we can say int row, it will be equal to floor I at ptnum divided by calls. This will be the row attribute, so we can actually assign it to an attribute. So we can say I at row, it will be equal to row. And let's have a look at that. So if we look at that attribute and we do marker, as you can see, we have 0, 1, 2, 3, and so on. So that is working. We can disable that visualization. And now let's do the same for the columns. In this case, we will call it call, and we will use the modulo operator in here. And we can copy this, and call it call, oops, and call. Let's see if that works. Looks like it's working. So 0, 1, 2, 3. So we have the call and we have the row, as you can see. So this can be useful for many different things. So it's always nice to know. I also want to get the maximum of each attribute. In this case, I only need the columns. So I'm just gonna set a detail attribute. Gonna call it max call. And it will be equal to I at call and as a max. I want to set it to the max. And we should have a detail attribute. So if we go in here, we have a 3 in the calls, and here in the max call we also have 3. So that is working. And now let's do this in a way that is more standard, let's say. So I want to select a random point on this side, on this column, and another random point on the left column. So we can do the following. We can create an attribute wrangle, and before that we need to sort randomly the points. So random in the point order and select the seed. And now we can do the following. We can read out the max call attribute. So int max call will be equal to detail incoming geometry or first input and max call. And then we can just create a variable or an array with all the points in the column 0 and in the last column. So we can do int start call array. It will be equal to expand point group incoming geometry and at call. So we have that attribute. We need to pass a string in here. So at call equals to 0. And now we can just say, we can create a group. So I at group start will be equal to I at ptnum if the point number is equal to start call, and we can just select the first entry in the array. So we can actually get this, copy this, and go in here and output selection group, we can say start. And as you can see, selecting that point. Let me see if I can increase in here. Sorry, it's in here, the point marker size under guides. So as you can see, selecting that point over there, and I can change the seed and select a different point. And now let's do the same for the end group, because we will create the shortest path between the starting point and an end point in here, and then do the random cut on the geometry. So let's get this one, and this will be the end call, and expand point group call is equals to itaway, and we want the last column, so we can do itaway max call, and now we can just copy this and say group end, and it will be equal to end call 0. So if we check this and go to points, we should have a last point and a first point, and let's randomize the order, and that's basically done. Now we can find the shortest path, and we can select in here the start and the end, start and end, and we get this random cut. We can possibly change the seed, and now we can just create a group. Let's go with edges, and let's also do a group transfer, and we want to transfer the group 1 and a really low threshold, so something like that. And now we also need to select the unshared edges, so unshared edges, and finally we can dissolve. So if we dissolve non-selected, the group 1 and the unshared, and we get this random cut on the geometry. And now we can do the lot subdivision. So lot subdivision, and we can play with the irregularity and reduce the iterations, play with this, and as you can see, we get a more randomized loop. If we play with the seed, we don't get that usual cut. Then probably play a bit more with this, and also create a visualization. So let's do I at class, it will be equal to I at prim num, so for each prim a different ID. Let's visualize that. So if we only did, so let's go in here and remove the group 1, so we have the flat plane, and we do the lot subdivision. As you can see, we have this obvious seam in here, and if we apply our cut, we get a more randomized look, and we can play with the seed and get different results, and we can also go back and play with this sort seed. So that's basically done, but there's another approach that I wanted to show you that might be interesting to know. So we basically solved our issue, but there's another way that I wanted to show you that involves iterating instead of points over numbers. Since we just want 2 points, so we only need 2 iterations, we don't need to iterate over all the points. It will be slightly more involved, but you might learn a thing or two, and we won't need these sort nodes, so we can just select a random point without sorting the points randomly. So let's create another. We will still need the column ID and the rows. So this time we will iterate over numbers, and since we just want 2 points, we can just set this to 2. So this will only iterate twice. And we will also need this max call, and we will need an expand point group, so we can just copy from here. So we have max call, and let's call this instead calls array. No, we want to call these groups, and we will work on it on a bit. So the first thing we need to do is to create an array of the columns we want to iterate over. So that should be simple. create a string, calls, array, and this is the only manual work we will have to do. So let's create an array, and it will contain the call 0 and the last column. So in this case, plus I to a max call. So those are the columns that we will iterate over. So the points on those columns. And now we can create this groups array where we expand the point group and we say 0, and we will recall this one. And as the index, we will use the I at lm num, so which is each iteration, which will be 0 in the first iteration and 1 in the second. That way it will select first the column 0 and then the last column. And we can use the same concepts to create random numbers and to set the point group. So for that, let's create a random number first. So int random, in this case it will be a random. So it will be a random of the lmnum, and we will use a seed parameter. And we can just multiply by the length of those groups, of those points, of that array, I mean. And then we need to also int it, so create an int from it. And just close bracket in here. And we should have a random number. And now we can set the point group. So set point group. Since we can't really use the I at group syntax, we need to actually set the point group. This is similar to iterating over detail, where we need actually to do some manual work. So I'm gonna call it group, and we need two groups, so I'm just gonna create here an I2A and use again the lmnum, so the iteration number, and we will set the groups from the groups array, the random number that we will generate, and we can just say set it at the end. And we should have those groups. So let's see, group 0, group 1, and we don't have group 1. Let's just create the seed, and it's selecting the same. It's selecting the same in the same column. Why is that? So sorry, I call these calls. It's call, not calls. So now it's selecting, and as you can see, selecting randomly one point on each side. And we don't need the sort node or a lot of iterations to solve this problem. Now we can just do the same in here. Unfortunately, I didn't find a way to rename the groups properly, so with a start and end. Maybe if we use a dictionary, but that will just be more work and we don't need to do that. So let's just say group 0 and group 1 and do this, and we can create in here a switch. And if we select the first input and now we transfer it and we do the dissolve, we get the random cut. And finally, we can create the lot subdivision. And let's play here with the seed. So, and we start to get a randomized result. So, a lot of work, but I hope you have learned a thing or two. It's always interesting how you can apply these run over numbers. Maybe it was not the best approach, but I found it interesting by using this lmnum as a seed and as an iterator to create multiple variables, let's say, for each iteration. But this is also valid. We just duplicated the code a bit in here, so we used the same commands over and over. So I found this one to be more efficient since we're just running over 2 iterations. So as always, you can grab the files on my Patreon alongside with exclusive tutorials on there, hours of exclusive step-by-step tutorials. I also have some courses in there if you want to check it out, and all the project files from my videos. So thank you for watching, and let me know what you think in the comments. See you!